This video, we're going to show an alternative way of solving quadratic equations without using the quadratic formula. This method was known thousands of years ago, but somehow it got lost. And Dr. Loh from Carnegie Mellon University, he rediscovered it. Should definitely check out his YouTube channel. He's a mathematician, and he's more than that. He's the brightest living mathematician. So let's get into this, and once again, go check out his channel. So what Dr. Loh rediscovered was the following. If you have, say, a quadratic equation where one root was x1 and one root was x2, and you have, let's call it m, the midpoint, that obviously the midpoint is equidistant from the endpoint, from x1 and x2. So x1 is basically m minus u, and x2 is m plus u. But let's get a better grip on what x1 and x2 are and what xm is. If you have a factored quadratic equation like this, where the roots are x1, x2, this multiplies out as follows: times x plus x1, x2. And if you notice, the product is the constant, the product of the two roots. And after the minus sign, that's the sum of the roots. It's important enough to write sum. That's the sum of the roots. But please, it comes after a minus sign. So, how about we do one of these? Now, just for the record, the midpoint is going to be the sum of the roots over 2, because that's how you find the midpoint of two numbers. You add them up and you divide it by 2. So basically what he's saying is, if you have x squared plus 5x plus 6, let me just make it negative. Negative 5x plus 6, and you want to find out when it equals 0. Well, if the roots are x1 and x2, well then we know that x1 times x2 is 6, and that x1 plus x2 is 5. Came after the minus sign. So basically, you want two numbers that multiply out this 6 and add up to 5. So we have x1, we have x2, and we have the middle point. And again, what he noticed is that these distances are the same. So x1 is m minus u, and x2 is m plus u. And we know what m is, but m is 5 over 2. It's the average of the sum of the two roots. Add them up, divide by 2. We know that the product of the two roots, on one hand, is m squared minus u squared. This multiplies out nicely, and it equals to x1, x2. And if you swap these two, you get that u squared is x1, x2 minus m squared. Now, u by design is positive. It's a distance. So u is just the square root of this. Now this is all in theory, these formulas or equations I'm writing. I'm not suggesting you need to memorize them. But we know that one root is x1 plus x2 over 2 minus u. this is, I guess, x1, and x2 is m plus u. M plus u. So, if you want, there's the formula. Yeah, I guess you could memorize this. Let me tell you, memorizing this is a lot easier than using this formula. It's a lot easier than the quadratic equation. And there shouldn't be a 2 down here. So, let me do an example again. Suppose we had x minus 5 times x minus 7 times x plus 5. This is x squared minus 2x minus 35. So, suppose we wanted to find the roots of this. When is it equals 0? And we don't know this. I mean, we know the answer is going to be 7 and negative 5. So, what Dr. Loh is suggesting is you take that number divided by 2. And that's the midpoint. There's the midpoint. So one root's going to be 1 minus u, and the other root is going to be 1 plus u. And when you multiply out the roots, you get negative 35. So all you have to do is divide that number by 2 and go minus u times 1 plus u. And it equals to the constant. So all you do is divide the number of x's by 2, and then 1 minus u, 1 plus u. And it equals negative 35. Well, this says that 1 minus u squared is negative 35. Bring that over, you get 36. Bring this over, you get u squared. So u is 6. Done. Done. This is the first root. That's the second root. 1 minus u, better known as 1 minus 6, and 1 plus u. U is 6. So the roots are negative 5 and 7. It's really quick. If you have x squared plus 7x plus 14. Remember, this number has to have a negative. This in front of it. This is the same as negative 7. So that's the number you take half of. Okay, if you like, if that's positive 7, you negate it, negative 7. If it were negative 7, if you did have x squared minus 7x, say plus 14, you negate that number. You negate negative 7, you get 7. Okay, so this here is the midpoint. So we know that the roots are the midpoint minus u times the midpoint plus u. But this is one root, that's the other root. And we're multiplying them. Oh, I know what we get. We get 14. It's just the way it is. So when you square that number, you get 49 over 4 minus, you square that, you get u squared, and wanting a 4 on the bottom, I'll multiply the top by 4 and the understood 1 by 4. So think of this as 64 over 4. You bring that over, you get, I guess, 25. That doesn't look right. You get negative 15 over 4 is equal to u squared. So u is the square root of, say, 15 times negative 1 over the square root of 4, which I know. So you get the square root of negative 1 times the square root of 15. That's u. Okay. And the midpoint is negative 7 over 2. So 1 root is negative 7 over 2 minus I square root of 15. And if you like, you can write it with a common denominator of 2. The other root is the midpoint plus I times the square root of 15 over 2, which is negative 7 plus I square root of 15 over 2. You don't need to use the quadratic formula. Now, notice that this only works when the coefficient in front of x is 1. Well, that's not going to be a big problem. If you had 3x plus 3x squared plus 6x plus 7, you want to know when it equals 0, divide by 3. Divide by 3. So you get x squared plus 2x plus 7/3. You negate that number, you get negative 2. You divide it by 2, you get negative 1. That is the midpoint. So 1 root will be negative 1 minus u. The other root will be negative 1 plus u. And that's the product of the two roots. Oh, that's going to equal to 7/3. So you have one number minus u, one number plus u. You're going to get the first number squared, which is 1, minus the second number squared. And this is equal to 7 over 3. Well, let's swap these. But I'll write 1 as 3 over 3. So we have 3 over 3 minus 7/3 is equal to u squared. That is negative 4 over 3 equals u squared. So u is the square root of negative 1 times the square root of 3 divided by the square root of 4. That's the square root of negative 1. That's the square root of 3. And the square root of 4 is 2. Well, I know my roots. Right now they're in terms of u, but now I know u. So it's negative 1 minus u. I square root is 3 over 2. That's one root. The other root is negative 1 plus I square root is 3 over 2. They work like magic. Except, as you all know, I messed up here, sorry. U is equal to the square root of negative 1 times the square root of 4 divided by the square root of 3. There's the square root of 4, there's the square root of negative 1, and there is the square root of 3. If I rationalize this by multiplying by 1, I get 2I square root of 3 over 3. So u is negative 1, which I'll write this way, plus u, common denominator, that's negative 3 plus 2y square root of 3, that's x2, and x1 is negative 1 minus u, which is negative 3 minus 2I square root of 3 over 3. Okay. This is really a clean way of doing this. Now, the last thing I like to show is this equivalent to the quadratic formula? Well, we know that the quadratic formula is negative b plus or minus the square root of b squared minus 4ac over 2a. But in our problems, A is always 1. So it's negative b plus or minus b squared minus 4c. Because 4 times 1, A is 1, 4 times 1 times c is 4c over 2 times 1, which is 2. Now, do we actually have it worked out somewhere in general? Oh, let's just work it out and show that this is equivalent to the quadratic formula. So we have that if you have x squared plus bx plus c equals 0, we'll think, so like I said, let's do it that way. We negate that and we divide it by 2. That's the midpoint. So one answer, x1 is going to be m minus u. It's going to be m minus u. And the other root is going to be m plus u. And their product, negative b over 2 minus u times negative b over 2 plus u is going to equal to their constant, c. So what we have is this squared, which is b squared over 4, minus that squared is equal to c. Interchanging these two, you have b squared over 4 minus c is u squared. I will multiply the c by 4 over 4. So now both fractions have the same denominator. So I know that b squared minus 4c over 4 is u squared. So then u will be the square root of this, actually plus minus, divided by the square root of 4, which we know. Now, we solve for what b is. We solve for what u is. However, the roots are negative b over 2 plus or minus u. And we solve for u. So x1 and x2 is negative b over 2. Just to be clear, one root is negative b over 2 minus u. The other root is negative b over 2 plus u. So we get negative b over 2 plus or minus u, which also has plus or minus. That's not going to affect anything. So the two roots are this here. Okay. But this is exactly the quadratic equation where a is 1. So we got it. And again, this method only works when a is 1. In fact, if you know that a is 1 in your quadratic equation, you could use this form of the quadratic equation, because all you're going to do after all is multiply by 1, and this will still be 4 times c, and this will still be 2. Okay, this completes this video. Definitely go check out Dr. Loh's website or his YouTube channel. You'll definitely learn some mathematics. Po-Shen Loh, greatest living mathematician right now. See you guys in the next video. Don't forget to hit the subscribe button, the like button. Please leave a comment. Never forget Tell all your friends and enemies about my channel. Watch and learn.